Yo, 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 this is Mr. O. Yo, 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 this is Mr. O, and today we're going to learn about quadratic inequalities. So, our goal is to graph quadratic inequalities in two variables and be able to solve quadratic inequalities in one variable. How do we do it? Let's do it now. So, first we are given y is equal to greater than x squared plus 2x plus 4. Some stuff that you have to know. First, we have two variables, x and y there. Okay. Next, this is greater than. Every time you have a greater than or greater than equal to, most likely you're going to shade above the graph. If you have a less than or less than or equal to, you're going to shade below, okay? Below the graph. But we will prove it how to check if we're doing the right way or not. We cannot just guess, oh, if it's greater than, it's always above. We have to verify it. That's what we're going to do in a while. Another thing we need to know is that if it's greater than or less than, there's no underline or equal to on the bottom, that should give you a dotted line. And when you have a greater than equal to or less than equal to, you know it's going to be a solid line, okay? Always remember. So now we have y is greater than x squared plus 2x plus 4. We're going to find the vertex here, as always, x equal to negative b over 2a. Negative 2 over 2 times 1, because this is your a, that's your b, that's your c. So you plug it into negative b over 2a, that will give us negative 2 over 2, which will be negative 1. So the vertex here will have a negative 1. And then you're going to plug in the negative 1 right back to the x. So this will be negative 1 squared plus 2 times negative 1 plus 4. This will be a 1, negative 2 plus 4. Negative 1 plus 4, it's 3. So therefore, the vertex is negative 1 comma 3. And you're going to go negative 1 up to here. The value of a here is positive. You're going to go up. Using 1, 3, 5, up 1 over, up 3 over, reflection on the other side. And if you notice, this is greater than, so it's going to be a dotted line. And we're going to shade here according to the instruction. If it's greater than, we're going to shade above. We assume the answer is this one. What if we don't remember this one? How do we know which one to shade here? Remember, first, we're doing the shading because it's inequality. But how do we know? Okay, let's say we do not know that's the correct answer. Pick the origin. It's always the simplest one. If you pick the origin. The origin has 0, 0 there. Means if you plug into the equation y greater than x squared plus 2x plus 4, let's see if it's going to give us a true or false statement. The value of y is 0 greater than the value of x is 0 squared plus 2 times 0 plus 4. If this gives us a true statement, then I'm wrong. We have to shade where the origin is. If this is a false one, then we have to keep our answer and we shade the above portion here. And 0 squared is 0. 2 times 0 is 0, so it's 4. Do you agree that 0 is greater than 4? The answer, that's a false statement. So we don't shade where the origin is, and we don't shade the outside part. So the answer is this one inside the parabola, the above portion. Next, y is less than or equal to negative 2x squared plus 3x plus 5. In this case here, we know it's going to be a solid, and our suspicion is going to be lower. The one outside the lower part of the graph is what will be shaded. I'm going to use the vertex formula, x equals negative 3 over 2 times negative 2 there. That will give us 3 over 4. It's going to be 3/4 or 0.75 here. And I'm plugging in the 0.75 here, negative 2. 0.75 squared plus 3, 0.75 plus 5 here. A 0.75 squared times 2 will give us negative 1.125 plus 3 times 0.75 is going to give me 2.25 plus 5 here. And minus 1.1 25. It gave me 6.125. So therefore, my vertex is 0.75 and 6.125 here. So before the 1, 6.25 is somewhere right here. And we know the graph is going down because it's going to be negative 2. Okay. Now, in this case here, it's a solid line because there's a line, so a solid line. And my suspicion is that it's going to be lower. The lower part of the graph is this the above, this is the lower part. But how do I prove it? Again, I'm going to try the origin. The origin is coincidentally is part of the possible shaded area, the origin. So I do hope that the it will give me a true statement. We know the origin is 0, 0. So 0 less than or equal to negative 2 times 0 squared plus 3 times 0 plus 5. We know 0 squared times 2 is 0. 3 times 2 is 0. So 0 is it less than or equal to 5? True or false? This is a true statement. So I know 0, 0 should be part of the solution. So everything right there should be the answer. So now let's try to solve x squared plus bx plus c less than or equal to 0 by graphing. We have to use the idea of the compound inequality. Compound inequality involves the n and the or. Remember, when it's n, you're finding the intersection of the common to the value of x. When it with or, you combine them, you put them all together. Okay. Now let's do this one here. Solve x squared plus 2x minus 8. Same way, we're going to find the vertex here, and x equal to negative b over 2a, x equal to negative 2 over 2 times 1. That will give you negative 2 over 2, which will be negative 1. And then you're going to plug in negative 1 there, which will be negative 1 squared plus 2 times negative 1 minus 8. This will be a 1 minus 2 minus 8. Negative 1 minus 8 is negative 9. So therefore, I'm going to go to negative 1, negative 9 right here. Since it's positive 1, I'm going to go do the 1 to 5 up 1 over, up 3 over, up 5 over. And then you do the same thing by reflection the other side. And there you have it. We will connect them and boom. Now here's the crucial part. We know that the key numbers here are the solution, which are the 2 and negative 4. We will do testing here. What do you mean by testing? We're gonna test if x is equal to, we're gonna pick a number on the left side of negative 4, between negative 4 and 2, and on the right side of 2. So let me pick, let's say, negative 5. I'm going to pick in the middle. Let's say 0 is the easiest one. And I'm going to pick here maybe these two, maybe 3. Okay, x equals 3. So it should give me a true statement right here in order for me to know if it's part of the solution. So if I put negative 5 here, it will give me negative 5 squared plus 2 times negative 5 minus 8 is less than or equal to 0. What's negative 5 squared? Negative 5 squared is 25. 2 times negative 5 is negative 10 minus 8 less than 0. This will give me 25 minus 18 is less than 0. 25 minus 18, it should be 7. Is 7 less than 0? Is this true or false? That is false. 7, 0 is not bigger than 7. So there should be no answer right here. So let's pick the middle one. Let's pick the 0. If you put the 0 there, 0 squared plus 2 times 0 minus 8 less than 0. 0 squared is 0. 2 times 0 is 0. Is negative 8 less than 0? Yes, this is true. So we know the answer will be from here to there so far. Let's try the 3. If we plug in the 3 there, so 3 squared plus 2 times 3 minus 8, this will be 9 plus 6 minus 8. This should be less than 0, less than 0. So therefore, this will be 15 minus 8 is 7. So is 7 less than 0? True or false? That's also false. So there should be no answer right here. The correct answer should be in the middle portion. So how do we write our answer here? Take note, this is a less than. If that's a less than, we expect that this should be open and open. So everything between -4 to 2, so the answer is from -4 to 2, the interval of that one. Or you can say in inequality that -4, no, no, hold on. You can say that x is greater than -4 and less than +2. So whichever you wanted here, it's correct. Good. This is interval notation. This is the inequality. Next, solve 0 greater than x squared plus 5x minus 6. We will do the same thing. Okay, you can find x equal to -5 over 2 times 1, which will give you -5 over 2, which is -2.5. You're going to plug in -2.5 right there and here. That will give us -2.5 squared plus 5 times -2.5 minus 6. That will give me -2.5 squared plus 5 times -2.5 minus 6. And that give us -12.25. So my vertex is -6. No, my vertex is -2.5 comma -12.25. Okay, -2.5 down -12.5 somewhere here. That's your vertex there. We know it goes up. This goes up there, goes up there, but we do not know what's the exact x-intercept. So there's because it's decimal, it's so hard to apply the 135. We will just guesstimate it. So what do we need to do? Let's do the factoring here. What two numbers, when you multiply them, gives you an x squared, which is x and x. When you multiply them, gives you -6. When you add them, gives you a +5. The answer is 6 and 1. This is positive, that's negative. And we know the value of x here are 1 and -6. So go to +1 and -6 right here. We know that if we connect the vertex to the x-intercept, it will be something like that and go up right here. Right? So now we will test it again. The crucial points are the -6. This is the 1. So we will pick a number on the left side of -6. We're going to pick a number on the right side of 1 and between them. So let me have space here. So let's try the test x is equal to -7. It's on the left side. So if we put a -7 there, it will be -7 squared plus 5 times -7 minus 6. 49 minus 35 minus 6. This will be 49 minus 41. And we know that this will give you, what's this, 8. And 0 less than 8. Because that's 0 greater than 8. Is 0 greater than 8? True or false? The answer is false. So we know there will be no answer again right there. Let's pick between -6 and 1, which is 0 is the easiest one. So let's test for 0. So 0 greater than 0 squared plus 5 times 0 minus 6. 0 squared is 0, 5 times 0. We know that 0 is greater than -6. True or false? The answer is true. So you know there's an answer there. So now we're going to try 2 there. So test x equals 2 here. So 0 greater than 2 squared plus 5 times 2 minus 6. 2 squared is 4. 5 times 2 is 10 minus 6. That will give us 14 minus 6 will be 0 greater than 8. True or false? That will give you false. So there should be no answer here. So the answer should be only somewhere in the middle between -6 and 1. Again, since there's no line here, this will be an open graph, open point there, parenthesis, parenthesis, and that's the answer.